C has two varieties of data type. First, primary, second, secondary. Primary data types are those which can't be divided any further. They are indivisible units, smallest in structure. Secondary data types are the ones which can be divided into smaller pieces. An example, array is defined as a collection of same or similar data types. So I can have an array of characters, I can have an array of integers. When I use the word array of characters, I bring in many characters or I bring in many primary data types together to make one secondary data type. Let's move further, uh, having a look at the examples of primary data types. As we all can see, we have defined a variable ch which is of type character holding a single char a. Age is an integer variable holding the value 33. Tax is a variable of type float holding 890.99. If my precision, that is the number of digits after the decimal, are much larger, then I need to use a variable of type double, because a float can't accommodate so many digits after the decimal. In simple way to remember, a float variable can accommodate 6 digits maximum after the decimal, and a double in C language can accommodate 12 digits after the decimal. We don't declare variables of type void because void per se is defined as null or nothing. Then the question arises that why is it there? It's there in C language to declare return type of functions. As an example, we have mentioned here void add int a comma int b. This means add is a function which accepts two integer variables a and b and returns nothing. When I use the word nothing, I mean to say a variable of type void. We move further to have a look at a few examples of secondary data types. I just mentioned some time ago that array is a collection of similar data type. Let's have a look at some examples. We have an array of integers in the first case, next an array of floats, and a third case array of characters. I'm sure you all are noting that a character is mentioned in single quotes. Now the problem that C programmers face is how do we collect or bring together dissimilar, not similar, dissimilar data types. For bringing together dissimilar data types, we have a variable data type called structure. Structure is a user defined data type or a secondary data type available to us in C language. Let's look at this family photograph. I see a father, a mother, two children, and two pets. If I intend to store the names of all these family members, I think the best structure would be an array. But if I want to store details of a single person, his name, his age, his salary, his gender, I don't think I can store it in an array. Why? Because, have a look at this. The details of a single member, name of the person, will be a set of characters, age will be an integer, gender would be a single character. Please notice you're trying to bring together different data types which can't be stored in a single array. So what we do is we define a structure, and a structure can hold or is capable of holding different data types. So here on we know the difference. We will use an array to hold similar information like array of names, And to hold dissimilar information, we will be using a structure which is identified by a keyword called struct in C language. We move further to understand more secondary data types. Moving on to the next, a pointer. A pointer in a C language is a special variable which holds the address of another variable. Let's take a real life example. I see a closet having all the stuff which we use daily kept in front of you. If somebody addresses me to bring these bags from here, he or she must point towards the bag. If you want anything from here, you have to point towards it. Otherwise, I won't know what to pick up. As an example, I have these bags here, so anybody who points towards these bags is indicating that please pick those bags for me. When a variable holds the address of another variable, that variable is called as a pointer. Now the question that comes to our mind is, what is this address? Like anything which is kept in this closet needs space, whether these shoes or the purses or the hats here, they are occupying space. In exactly the same way, any variable which is declared in C language needs space in the computer's memory, and anybody who points towards that space is called as a pointer. We move further. The next secondary data type is a union. A union is similar to a struct, but it consumes less space. We will see more about it sometime later. Enum stands for collection of string constants. This is an example. I am declaring here signal underscore colors as a variable of type enum, that is enumeration. If here after I declare any variable, let's say var of the data type signal underscore colors, I can't store any value in var other than red, yellow or green. So enum data type in C language creates for us a simple set so that a person declaring a variable of the enum can only use variables or values from those set. Let's have a look at the next part. We have something called as modifiers. There are 4 modifiers available to us in C language: short, long, which talk with respect to the size of the data. Short will reduce the size of a data type, long will increase the size of the data type. Signed and unsigned are self-explanatory. Signed indicates that a variable can hold positive and negative values both. Unsigned means you cannot put a negative value. You only have to hold a positive value. Modifiers are a lot dependent on the operating system. Just as an example, a int variable over Windows consumes a 2 bytes of space. So a long int would increase the size of an integer to 4 bytes. Similarly, a short int would either keep the size of the integer to same as 2 bytes or reduce it to 1 byte. These modifiers are quite often used in C language for ensuring that large values can be stored by using the modifier called long, and to also ensure that we are not allowed to store negative values at times, and we ensure it by using the variable with an unsigned modifier. Let's take an example. I just mentioned some time ago that modifier size depends upon the operating system. Let's look at this. Short int a is going to consume a space of 2 bytes or 16 bits. If an integer by default takes 2 bytes, then a short int will not reduce its size, it will also end up taking 2 bytes. But if an int takes 2 bytes, then a long int would definitely increase its size to 32 bits. Vice versa, if an integer is by default taking a space of 32 bits, that is 4 bytes, then a short int ends up reducing its size to 16 bits or 2 bytes. Fine, seems a little confusing. Let me put it in very short. If your integer's default size is 2 bytes, then long int increases it to 4 bytes. If your default int's size is 4 bytes, then short int reduces it to 2 bytes. So short int will reduce the size only if the integer by default is 4 bytes, and long int would increase the size only if the default size of the integer is 2 bytes. Well, let's move further to qualifiers. Qualifiers are next important thing in C language. We have two qualifiers, very simple, const and volatile. Const means constant, volatile means something which changes. Let's take a simple example. Declared a variable pi as float and it's been qualified as const, that means constant. After we have done with a variable as const and stored a value 3.142 or any value of your choice, you can't change this value hereafter in the program. If you attempt to do so, there would be a compile time error. Next, looking at the example of the volatile variable. Volatile indicates that the value of the variable a would change in the due course of the program. By default, any variable which we declare in any programming language, C, C++ or Java, is meant to change, and hence volatile is something which is by default. Even if we don't mention volatile before the variable, it is by default a volatile variable because it's going to change over the period of time. We move on further. Right. We move on to the next topic, formatted input output. Here we would be accepting some input character like say a by using the function getch, and understanding of how we can print it right justified and left justified. I assume that all my audiences know how to print a character by using %c. The number which is put between the percentage and the format specifier indicates the space that should be booked before we print the character. For example, %5c would book a space of 5 and then print the character ch. A %-5c would also book a space of 5 but would print the character left justified, something like this. 5 spaces, a comes on the right side. Here 5 spaces, a comes on the left side. When I print hello, I see a first on the right side because of the first printf statement, then I see a on the left because of the next printf statement, and then I see hello on the extreme right hand side. So we memorize this. If it's a positive number, it's right justified. It's a negative number, it's left justified. Now if I want to pad zeros with the space left on the left hand side, I can do that by writing %05d. 5 indicates space of 5, d indicates that we're trying to print a number, and 0 indicates that we are appending or adding zeros to the left. Moving further, let's think we have stored a float 4.5678 into the variable a, and we are interested to print this with the precision of 2 digits. A 2-digit precision means after the decimal point we are going to just print 2 digits, But yes, with the basic rule of mathematics, we will be rounding. So it's 4.56 rounded to the next digit. 4.57 should be the output for percentage point to f. Please notice, before the point there is no number put, indicating that we are not putting any restriction on the size of this number. We are not bothered of how many digits are there before the decimal or after the decimal. But yes, when we're going to print this, we wouldn't allow more than 2 digits after the decimal. Let's all derive the output of this particular program. You have 30 seconds in hand. Please start. Yes, I believe all you guys are ready with the answer. Please verify your answer. Something like this. First, we have printed the variable a in a space of 5. So, 2 spaces and then the number 100. Then we have 5.2f, that means total of 5 spaces in which we are printing a float. 2.71 because we need just 2 digits after the decimal, so 71 will get rounded off to 72, so it's 2.72, and then it's a variable x. Right, we end our first session of data types with a list of format specifiers. In these format specifiers, the list is very clear. We need to remember that to print any data type in a printf statement or to accept its value in a scanf statement, we use search format specifiers where %c indicates character, %d or %i indicates integer, so on and so forth. Things to remember which we should not make a mistake: a %small l indicates a long int and a %capital LF indicates a long float. Thank you all. If you have any queries, you can always mail me or communicate with me on the following. Yes, so we ended today's session on data types and format specifiers. If you have any queries or any feedback, you're most welcome to mail me at rocky@swainconsultants.com, and I teach the following subjects. You can always visit the link tpo.swainconsultants.com for having more information on certification courses which I take at our training centers and at various colleges. And that's me, guys. All the best. Thank you.